Good evening, all. Could you please confirm, am I audible to you and is my screen visible to you? Yes. Okay, that's fine. That's fine. Okay, no need of further confirming. Thank you. Yes, thank you. Thank you. Okay. Like every other session, even in the today's session, we'll start with a small recapitulation, followed by we'll discuss about the today's topics. First, I start my discussion with the agenda of the today's session. Okay. Then we'll have a small recapitulation, followed by the today's topics. Okay. Now, okay. Agenda of the today's session is today we'll discuss about the retrieval augmented generation, and we'll see how to implement this retrieval augmented generation using very recent data. Along with that, we'll discuss about how to build an agent. How to build an agent by that is nothing but attaching LLM or binding LLM with a tool. Just binding LLM with a tool. These are the two things we are going to discuss in the today's session. And And first we'll have a small recap. Followed by this, we'll discuss about the today's topics. Okay. Now, what did we discuss in the last session? What did we discuss in the last session? Okay, LangChain. Building an application with the LangChain. Perfect. Okay. In the last session, we have seen the three main components in the LangChain. That is chat model, then a prompt template or precisely chat prompt template. Along with that, we have discussed about this output parser, and particularly we have discussed about the string output parser. Yes. And after discussion on these three, we have discussed about the behavior of chain. After discussion on the behavior of chain, we have discussed we have built a small LangChain application which can convert the given content into a neat web article. Yes. Okay. Now, in the last session, we have discussed about the LangChain, and in the LangChain, we have discussed about three main components in the LangChain, out of which one is called as model, and very precisely, it is a chat model. And we have discussed why is it called as chat model, because this can accept a list of messages. Because this can accept a list of messages, or this chat models can accept a list of messages. Thereby, we call these models as a chat models. Followed by that, we had discussed about the prompt template. Prompt template, as we are all aware, okay, prompt is an input to any generative AI system, or prompt is an input to any large language model. But to give the prompt, this is one way possible. Thereby, it is possible to create a template, and if you want, you can edit this template and give a prompt to the LLM. Okay. In the prompt template, again, we have discussed about something called as a chat prompt template. And we are aware that whenever the chat is assigned before the name, or whenever an adjective chat is added, it's an indication that this chat prompt template can accept the multiple messages. Multiple messages or multiple instructions or prompts. Like it can, in the chat prompt template, you can give a list of prompts or a list of messages starting with a system message, a human message, nothing but the user message, a AI message, nothing but the assistant message. Okay. You can give a list of messages as an input to the prompt template. Then after discussion on the prompt template, we have discussed about the string output parser. Whenever you give a prompt as an input to the model, or a chat prompt template as an input to the chat model, it directly returns the text. It don't directly returns the text. It do not directly returns the text. It returns something called as AI message as an output. It returns AI message as an output. Now to convert this AI message to the text, we need some parser, we need some cleaning operation, and that cleaning is the string output parser. The string output parser will convert the AI message to the text. Okay, and not only string output parser, in the LangChain, you have many other output parsers available. One is the comma separated list output parser. Second one is the Pydantic parser. Third one is the JSON parser. Okay, these parsers are used to, or these parsers are helpful whenever you want, or these parsers rather than use it. These parsers make LLM return, okay, a list or a Pydantic object or a JSON as an output. Okay, if you look at the string output parser, it converts the AI message into the string. But if you look at the other parsers like list, Pydantic, and JSON output parsers, these parsers are used to make LLM give the output in the form of a list if you use the comma separated list output parser, Pydantic object if you use the Pydantic output parser, and JSON if you use the JSON output parser. Okay, these are the three main components in every LangChain workflow. Okay, now these three main components components of the LangChain workflow is connected with an operator called as pipe operator in this way: prompt template, pipe, model, pipe, parser. Okay, then and whenever you connect these three elements in the form of a chain with the help of pipe operator, it is called as chain. Now, how the elements in this chain behave? Okay, whenever you provide input to the prompt template, as we discussed, prompt template you can run the prompt template using invoke, and if you invoke the prompt template, you will get prompt as an output. And the output of the first stage is fed into the input to the second stage. Whenever you give prompt as an input to the model, this model returns AI message as an output. And the output of the second stage is fed as an input to the third stage. Whenever you provide AI message as an input, and this parser returns text as an output. This is how chain or elements in the chain interacts. Okay, if I give prompt template as a first stage, then no need to give input to all the three stages. If whenever I give input to the first stage, the output of the first stage is fed into the input of the second stage, and output of the second stage is fed into the input to the third stage, output of the third stage to the fourth stage, output of the fourth stage to fifth stage, so on and so forth. You can build any number of elements in the form of a chain. And to run every element in a chain, if you want to run prompt template, use the method named as invoke. If you want to run the model, how to run the model? With the help of invoke. And if you want to run the parser, how to run the parser? With the help of invoke. And even if you want to run the chain, to run the chain, use the method invoke. Invoke is the method used to run the individual elements of a chain and the whole chain. And whenever you invoke the whole chain, no need to provide input to all the three stages. Just provide input to the first stage. Output of the first stage is fed into the input to the second stage. Output of the second stage fed into the input to the third stage, so on and so forth. Okay, this is how a chain is built. Okay, I got two queries. Pydantic means what? Okay, this is a good question. Okay. Pydantic is very similar to the Python class. It's a Pydantic model. A Pydantic model is very similar to the Python class. But one advantage with the Pydantic model, if you want to create a Pydantic model, it is very similar to the creation of the Python class. But whenever you create a Python class, whenever you create a Python class by inheriting okay, a parent class as base model, a parent class as base model, and this base model is from the Pydantic library. That is from Pydantic import base model, and if you import this base model as a parent class, and sorry, if you inherit this base model as a parent class by creating any class, for example, my class is like this: class validate input, and I'm inheriting a parent class or a class named as base model. Okay. Then for example, if I write input as a string, and if I write number as a integer, then this Python class will validate the inputs. There is one main problem with the Python is that most of you are aware. One main problem with the Python is dynamically typed. Python is dynamically typed or dynamically typed. For example, if I create a is equal to 3 at the starting of the program, in the middle of the program, I can change this a is equal to some string. At the end of the program, I can change this a is equal to a list. Okay, Python is dynamically typed. Okay, because Python is dynamically typed. Okay, a variable. For example, if I start with the input, at one point input takes a string, at another point input takes an integer, and the third point input take a list, and the fourth point input becomes an object of a class. Okay, anything that input can assume. Okay, and this creates a problem whenever I build an application. Whenever I build an application with some input, and this application returns the output. Okay, and in the input there are some variables I need to give input to the model, like one is the input, another is the number. Okay, over a period of time, this input and number may change its data type because of the dynamically typed nature of Python. To validate whether this input is a string, whether this number is an integer or not, to validate the type of the input parameters, the Pydantic models are mostly used. Input parameters that Pydantic models are mostly used. Along with that, if you return output as a Pydantic model, okay, if you make LLM to return output as a Pydantic model, thereby you can convert this Pydantic model. Sorry, if you make your LLM to return output as a Pydantic object, thereby you can further convert this Pydantic object as a JSON, and from the JSON you can read some fields, and these fields can be used as a input to the other chains or other elements in the chain. Okay, Pydantic objects or Pydantic classes. Okay, in fact, Pydantic models are used to validate your input and validate your outputs. Okay, because of the Python's dynamically typed nature, validation is quite needed, and for validation, these Pydantic models are used. Okay, fine. Then now in the today's session, we'll start. Okay, we'll start the today's topics. The first topic is the retrieval augmented generation RAG. Retrieval augmented generation. Already we have discussed about what is the use of RAG. Can anyone please respond me what is, okay, we need to discuss about what is RAG. Then already we have discussed about why RAG. Okay, now we'll discuss very elaborately about what is RAG. retrieval augmented generation. No need to anyone answer this question. I'll answer this question. Now my question is why RAG? Okay. I'll discuss very elaborately what is RAG. Now I want to know from you why RAG. Already we have discussed during our discussion on the introduction to the LangChain. That is date at the end of the day 2. Sorry, day 3. Us to build an application using proprietary data. Perfect. Two answers are here. And second one is whenever your LLM is not equipped with the very recent data, in such cases, with the help of retrieval augmented generation, you can add the proprietary data to the model, and you can add the very recent data to the model. Perfect answers. Okay, I'll write here. Why RAG? First one is whenever you want to build, okay, LLMs are trained only on the public data. Trained only on the public data. If you want to build an application using, any proprietary data which is accessible to a small set of people, or data which is accessible to the only particular organization people, if you want to build any application using proprietary data, because if you look at the data which is available within an organization, a huge amount of data are available with the organization. An employee cannot go through the huge amount of data and get the required things out of it. Thereby most of the organizations really want to build an application which can provide information about the which can provide information about the data available with the organization. Okay. In such cases, because this proprietary data is not accessible by the LLMs are failed to answer these questions. LLMs fail to answer these questions. Then one way we need to build this application is, okay, add this data to the LLM. Add this data to the LLM. Thereby, you can build an application. That is, you can thereby all the capabilities of LLMs can be used. Just whenever you add this data, all the capabilities, the reasoning capability of LLM, okay, and translation capability of LLM, you can use all the capabilities of the LLM, and you can get a very good application. This is the first reason why we are using this RAG. And the second reason is, if all the LLMs have some cutoff date. All the LLMs have some cutoff date or the last updated date. Clear. Okay. All the LLMs have some cutoff date. It is the date when LLM last updated. It's the date when LLM, okay, rather than writing LLM, information in the LLM last updated. Information in the LLM last updated. Okay. If you ask any query, prior to this date, prior to the date, prior to the cutoff date, LLM can easily answer the query. But if you ask any question, post the cutoff date, any query post cutoff date, thereby LLMs fail to answer. In such cases, RAG applications are useful. RAG applications are useful. And one more caveat I want to communicate with the RAG, or one more thing I want to communicate with the RAG is, for example, if the information is small, if the information or if the data, proprietary data or recent information, the proprietary data, or the recent information you want to add, the recent information, the information in the form of proprietary data, in the form of recent information, you want to add to the LLM. You want to add to the LLM. If this is very small amount of information, no need to build any RAG. If it is very small amount, then no need to build any RAG. What you can do is just add this information. What you can do is just add this information to the prompt. Add this information to your prompt. Add the small amount of information. Add the information to the prompt. Like, for example, let us say this is my prompt template. Prompt template is equal to chat prompt template of a list of messages. Okay, like in the system message. In the system message, just add the your proprietary or your recent information. And in the human prompt and the human message, ask your query. Okay. If the information is small, no need to build any RAG. You can directly add this information to the prompt. Okay. Then directly LLM is aware of this information. LLM will answer based on the given information. Okay. If the information is quite large, okay. And the next case is if the information is very large amount. If the information is very large, or we have very large amount of data, in such cases, again you cannot build the RAG, or again you cannot use the RAG. It is not economical. It is not economical. It is not economical, and it is not fast also. It is very slow. It will be very slow. In such cases, if the information is very large, instead of using RAG, there's one more option available. Maybe some of you are aware of this option. It is called as fine-tune. Go with the fine-tuning. Don't use the RAG. Even if you use the RAG, because of the large amount of data you have, mostly the data is stored in the vector databases, and these vector databases are if you use any cloud vector database, it is quite costly. And if you use your own data vector database, and if you host any vector database, it consumes a lot of memory. And along with that, because you have stored a large amount of data, searching in the data becomes quite tough, or it takes a lot of time. Thereby, it takes more amount of time to respond to your queries. Okay. Whenever you have a large amount of information, it is not economical to have the RAG, and the response from the RAG application will be very slow. Whenever you have small amount of information, no need of going to the RAG. Directly you can add this information to the prompt. Okay. Whenever you have a moderate amount of information, okay, whenever I say the small amount of information, the amount of projected information in the model, I cannot directly say the information. The amount of projected, I'll use another ink, thereby I can differentiate it well. The amount of the projected information handled by the model should be less than the context window. Should be less than the context window. Context window is the maximum number of tokens an LLM can accept as an input. Okay, if your projected amount of information to the model is less than the context window, then you can use it. Okay, fine. Now we'll start our discussion on the RAG. RAG is retrieval augmented generation. Augmented generation. Out of these three words, we are very much aware of this generation. What is this generation? What is this generation? Generation is nothing but generating the content or generating the text in case of large language models. Generating the text. Okay. Whenever you have a large language model available, and whenever this large language model generates the text, it is called as generation. Generating the text as an output or generating the text is called as generation. Now, to have this generation, okay, what is required? What is required to generate the text? Okay, maybe this question seems very abstract to you, but the same question I have asked in the first session also. What is required to generate the text? Yes, prompt or query. Perfect, perfect. Uh, okay. Even algorithm is fine, but whenever I write LLM here, already it is processed through the algorithm. No, and there is no there is no context here. There is no clue or idea about there is no choice for the algorithm here. In fact, okay, whenever I write LLM is an output of an algorithm. No need of specifying it as an algorithm. No. What is required to generate the text? In order to generate the text, an input is required. In order to generate a text, an input is required. An input is required and an input is required, and we call this input as a prompt. Whenever I say prompt, we have already discussed about the ingredients of a prompt. There are mainly three ingredients in a prompt. One is the customer query that we have already seen. Second one is the examples. Again, we have already seen this during our discussion on the prompt templates. And third one is the context. The context required to answer the query. The context required to answer the query. The context required to answer the query. This is the third one. Now, today we'll be mainly focusing on this context. Adding context to the query, thereby your LLM will respond to your questions very precisely. Okay. Yes. Now we'll start our discussion on the remaining two words. Okay. Now, before starting our discussion on the remaining two words, I just want to know what is the literal meaning of augmented? What is the literal meaning of augmented? With the help of. Perfect. Any other? Yes, a proper input query is a good answer. Any other? Literal meaning of augmented is with the help of. Yes, collaboration. Coordination. Added. Added is also a good one. Added, enhanced. Okay. Literal with the help of, or I can say by adding something, or which enhances. Okay, this is the augmented. Now write a statement here. Okay, in the retrieval augmented generation, our generation is augmented. Okay, based on these three. All right, our generation is or the output, not our generation, output generation or response generation. Okay. The response generation is improved is improved with the help of, okay, or response generation is enhanced with the help of, with the help of retrieval process. Enhanced or improved with the help of a retrieval process. Okay, the generation what we are discussing here, the output from whenever user asks a query, the output which is the output what we are getting, it is called as generation by the LLM. This generation is improved or enhanced with the help of a process named as retrieval process. A process named as retrieval process, and this is communicated by the augmented. This is communicated by the augmented. Now, what is this retrieval process? Retrieval. Now, I have two queries are bigger in some way. Supplement. Supplement is also a good answer, in fact. I'll write here. Supplement. Supplement. Or supplement. Perfect. Now, retrieval. What is this retrieval? Retrieval is nothing but just taking out, or I can say, whenever. Okay, what is required to get a generation? An input is required. Whenever user sends an input or user asks an input query, okay, I hope some responses. I got some responses for retrieval too. This is good. Fetch, perfect. Based on the chunk of input data provided to the LLM, output generate extract. Yes, perfect. Okay, I think I have not discussed about this chunking and all. Maybe you are aware of this process. That is even fine. Get the data required by asking the. Okay, fine. Whenever user asks a query, okay, now to answer this query, effectively, or for better generation, or for better generation, of response, we add or we supplement our query. We add or supplement our query with some context or with some relevant context. Okay, adding a relevant context to the query, thereby our output or response generation becomes enhanced. And this adding the relevant context to the query is called as is the process of retrieval. All right, here adding the relevant context to the query. Adding the relevant context to the query a relevant context to the query is a retrieval process. Not retrieving. It is the process of retrieval. The whole idea of the retrieval, not the retrieval, or not the meaning of retrieval, is the whole idea of the retrieval process. Add the relevant context to the query. Now, how to get this relevant context to the query? How to get the relevant context to the query? Okay. In order to get the relevant context to the query, okay, we compare our query with the we compare our query with the proprietary data or new data you are using to build the RAG system. Proprietary data or new data you are using to build the RAG system. Now, how to compare two texts? Is it possible to compare two pieces of text? In fact, it is not possible to directly compare the two pieces of text. For this comparison, we'll be using the similarity search. Similarity search of vectors. Or we call these vectors as the word embeddings. We call these vectors as the word embeddings. Okay, this is the query word embedding. Is compared with the proprietary data. Okay, first we divide the proprietary data into the chunks, or we divide the proprietary data into the chunks, and then we compare the word embeddings of the chunks of proprietary data. Word embedding of chunks of proprietary data, pieces of proprietary data with the word embeddings of the query. Now, what is this word embedding? Okay, word embedding is nothing but a numerical representation of a sentence for sentences and even for words available. A numerical representation of the words. Or whenever I say sentence embeddings, it is a numerical representation of the sentences. In case of RAG, we are interested at this sentence embedding. I'm sorry. I'll write sentence embeddings. Sentence embeddings, and here it is a sentence embeddings. Okay. Compare the sentence embeddings of the query with the sentence embeddings of the all the pieces of text which is available in the proprietary data. Thereby, we'll perform a similarity search. Okay. And then what is the sentence embeddings or word embeddings? Is the numerical representation of the word or sentences. And in order to get this numerical representation, the models are trained on the data. Models are trained on the text data. For tasks like masked language prediction. For tasks like masked language, not prediction, modeling. LANGUAGE. Masked language modeling or next sentence prediction. For the sentences, it is the next sentence prediction. Okay. Like it is like training our large language model. These are also trainings. Just train for the masked language modeling or train for the next sentence prediction. That is, hope you understand what is the second one. Whenever I give input as my first sentence, then the next sentence should be predicted by the model. It is called as next sentence prediction. Thereby, it is possible to create the sentence embeddings, or it is possible to learn the sentence embeddings. In the same way, what is this masked language modeling? That is, you give input to the model during training. Whenever you give the first sentence as input and your model is able to predict the next sentence, it is called as next sentence prediction task. In the same way, whenever you give a masked word or a masked sentence as an input, and in that from the training, if your model can predict the masked word, this is the masked word. Your model can predict the masked word. It is called as masked language modeling. Through this masked language modeling, or through this next sentence prediction. Through the masked language modeling, our models can learn the word embeddings, and through the next sentence predictions, our models can learn the sentence embeddings. Okay, through these sentence embeddings are obtained. When our sentence embeddings are obtained, then we can convert whenever you provide a sentence as input to the sentence embedding model, and we'll see one such sentence embedding model in our discussion today. It is called as sentence transformer. Whenever you use a sentence embedding model, okay, whenever you give a sentence as an input to the sentence embedding model, it will convert the given sentence into a vector of some numbers like this: 0.5, 0.002, 0.1, 0.005, so on and so forth. Okay, whenever you give a sentence as an input, then that sentence is converted into a vector. These type of models are called as sentence embedding models. There are many sentence embedding models available. Okay, and if you look at this Gemini API we are using, Gemini has their own sentence embedding model available. GPT has their own sentence embedding model available. And if you want to use any open source sentence embedding model, even open source sentence embedding model is available. It is called as sentence transformer. And whenever you provide a sentence as an input, then you'll get the vector as an output. Okay. Now give the query to the sentence transformer. Thereby, whenever you give the query to the a sentence embedding model, or we cannot call always a sentence embedding model. We always refer it as an embedding model. You will get output as a query embedding. In the form of a numerical vector. In the same way, whenever you have the proprietary data available, just split this data into chunks or small pieces, and give every chunk to the embedding model and an embedding vector is returned for every chunk. For the first chunk, embedding vector 1, second chunk, embedding vector 2, third chunk, embedding vector 3, up to so on and so forth. For example, if you divide your data into 100 chunks, you will get the 100 vectors. Now compare your query embedding with the the chunk embeddings are embeddings of the proprietary data chunks. The chunk embeddings. For the first chunk embedding, second chunk embedding, up to so on and so forth till 100 chunk embedding. Compare your query embedding with all these chunk embeddings. Then how to compare? Whenever you want to compare, one very good metric to compare is just to find out the cosine similarity. Find out the cosine similarity, or it is very similar to find out the dot product. Query embedding dot chunk embedding 1, and you'll get some value. Very similar to the dot product, not exactly same as the dot product. Very similar to the dot. Okay. Now, whenever the value is high, then it is an indication that the query and chunk are similar. Whenever I say similar, belongs to the similar context. And whenever this value, the query embedding dot chunk embedding value or cosine similarity value is very low, Whenever it is very low, it is an indication that it is dissimilar. Dissimilar or both belongs to the different contexts. Both belongs to the different contexts. But in the RAG, we are interested chunks which are very similar to the query embedding. Okay. Thereby, for every chunk, cosine similarity is calculated. And mostly this cosine similarity values are between 0 to 1. Okay. And once you find the cosine similarity with all the chunks, for example, this is 0.75, 0.5, 0.02, so on and so forth. Okay. Find out all these cosine similarities between query and the embedding. Okay. Q and chunk 1, let us say 0.75. Q and chunk 2, 0.8. Q and chunk 3, 0.2. Q and chunk 4, 0.5. So on and so forth. Q and chunk 100, 0.02. Okay, this is how cosine similarities are found, are calculated. Once cosine similarities are calculated, find out the most similar chunks from the proprietary data, or retrieve the most similar. What is this most similar? Cosine similarity values near to the cosine similarity values are high. Retrieve the most similar chunks from the proprietary data. Cosine similarity values are high whenever I say most similar. Retrieve the most similar chunks from the proprietary data. And add these most similar chunks to the prompt. Add the most similar chunks to the prompt. And this most similar chunks to the prompt I have previously referred as the context. Add this context to the prompt, thereby your generation will be enhanced. And in order to carry out this process, our query is available with us, but all these chunks of proprietary data are stored in a database. To carry out this process efficiently, the retrieval process efficiently, then the proprietary data, or the chunks of the proprietary data, is stored into vector database. From the vector database, retrieving the vectors is quite quick or quite fast. The retrieving the vectors is very fast from the vector database. Thereby, all the chunks of this proprietary data is stored into a vector database. Okay. Just compare your query with all the chunks of the vector database. Find out the top or most similar chunks to the query. Whenever I say most similar chunks, similar context. Okay. Find out the most similar context to the query and add these chunks to the prompt. And this prompt with this added chunks as an input to the model, thereby generation will be enhanced. And this process is called as retrieval augmented generation. I have few queries. Get the data required by the query. Designing the prompt in such a way that content is also mentioned. Context is also mentioned. Yes, we have discussed about it. The first option, whenever the amount of data is small, you can add the data to the prompt. Could you please repeat this again? I could not. Fine, that is fine. I'll do it. Again, I'll do it. Kindly provide Okay, what is the model used for creation of the word embeddings for a sentence? A lot of models available, but in this session we'll be using this sentence transformer models, sentence transformer embeddings. What is Q? Q is the query. Okay, now we'll discuss the same with one very good article I used to refer for this. It is Decoding AI's article. Decoding AI fundamentals of RAG. Yes. This is a very good diagram to understand the RAG. Okay, if time permits, just try to read this article too. This will help you to understand the subtleties of this or some subtle points of this RAG too. Okay, now we'll start our discussion. What is the first one? Whenever user asks a query, convert this query into the input embedding. Whenever user asks a query, use some embedding model. Okay, like a sentence transformer model. And convert this query, which is in the form of text, to the query, whenever I say embedding, which is in the form of a vector. A vector like 0.05, 0.2, so on and so forth. A vector. Okay. This is the first part. Then now why are we doing this? For the retrieval. What to retrieve? Just store your okay. Then take your proprietary data. Okay. This is the data source is your proprietary data. Take your proprietary data, clean your proprietary data, chunk make it into the pieces. Chunk your proprietary data, and with the help of the same vector embedding what we are using, the same embedding model what we are using here, with the help of the same embedding model, okay, convert these chunks into the same embedding model. Convert these chunks into the vectors. Let us say I have 100 chunks available. The whole data is divided into 100 chunks. Or I can say in my data, I have 100 lines available. I am considering every line as a chunk. 100 chunks, thereby chunk 1, chunk 2, up to so on till chunk 100. For every chunk which is in the form of text is converted into a vector. Text is converted into a vector. Okay, like 0.5, 0.2, 0.2, 0.6, 0.1, 0.3, so on and so forth. Vectors. Okay, now take your input query, use an embedding model, convert your text query to the vector. In the same way, take your proprietary data, clean the data, divide the data into the pieces, and convert every chunk into the embedding. Now compare your query. I am referring this query as a Q and chunk as a CI. Okay. Compare your query Q with the chunk C1. Find out the cosine similarity score. Let us say 0.75. Okay. Or check the similarity. I'll write here. Check the similarity. And the name of the similarity we frequently use is the cosine similarity. Check the similarity, and the values of cosine similarity are between 0 to 1. Check the similarity of query and chunk 1, query and chunk 2. Let us say 0.2, query and chunk 3. Let us say 0.05. So on so forth till query and chunk 100. Let us say 0.9. Okay. These are the similarity values between query and every chunk available in the proprietary data or in the data source. Okay. Okay. Compare the query with the every chunk. Okay. Once you compare these two, for the sake of comparison, we keep all these chunks into a database named as vector database. Into a database named as vector database. And after you compare this query with the chunks, pick the let us say top five chunks. Pick the top 5 chunks. If you want, you can have top 10 chunks or top 20 chunks. It's up to us. Pick the top 5 chunks. What is this top 5 chunks? Okay, the chunks which are having high similarity score. The chunks which are having high similarity score. Pick the top 5 chunks. Okay, let us say these are the 5 chunks. These are the 5 chunks. Now add these 5 chunks to the your prompt, which is or your user query, which is converted into the prompt template. Add these 5 chunks, and by adding these 5 chunks, create a prompt, give the prompt to the LLM. Thereby you will get the generated answer as an output. This is the retrieval augmented generation or basic retrieval augmented generation. There are mainly 3 parts here. The first part is convert the user query into the user query in the form of text to the user query in the form of a vector with the help of an embedding model. Then take the whole proprietary data and divide this proprietary data into the pieces and convert every piece into the vector embedding. Then compare query with the every chunk or every piece of the vector embedding. Find out the similarity scores. Once you find the similarity scores, get the top 5 similarity scores. And get the top 5 similarity score chunks. Pick the top 5 chunks of this top 5 similarity score chunks and add this top 5 chunks of data to the prompt. And give this prompt to the LLM. Thereby LLM will give the response. This is the retrieval augmented generation. Yes, I'll show you. Perfect. This is the retrieval augmented generation. Okay. Now we will see the same in the form of code now. All day in the notebook, I have added the whole code today rather than writing. Writing takes a lot of time, but I use the same constructs. Okay. Now we'll start with the RAG. Okay, one thing you need to do is you must import your whenever you have your Gemini model available in the secrets, and if you provide this Gemini model key here, that is enough. Okay, I'll share the notebook link again. Yes. Now we'll start with this. First, I have imported the model. And many of you are aware how to import a model with the help of Init chat model. Already we have discussed in the last session. Have imported the Gemini 2.5 Flash Lite model. Once I import this Gemini 2.5 Flash Lite model, now I have asked a query to the model. The queries briefly explain the idea of Harness API. Idea of the Harness API article published on 21st May 2026. That is very recently, yesterday, one article. This is really a good article. I have gone through this article, not very in depth, but I have just read the article or I skimmed this article once. So it seems like a very promising or very good article. Yesterday it is published and it is available in the archives. Cornell University archive, it is available. Okay, now I have asked LLM that just briefly explain the idea of this Harness API article, which is published in the 21st May 2026. I have asked this query to the LLM. Okay, in order to ask the query, I have created a prompt and I have given that prompt as an input to the LLM. Thereby, just look at this LLM response. I cannot provide information about the article published on May 21, 2026. Yes, this date is in the future. Such article does not exist. Okay, that is, this LLM is trained on the past data and this is the future data for the LLM. Thereby, LLM is unable to respond or unable to explain this data, unable to explain this idea to the user. Okay. Now, if the amount of data which is available in the article is quite small, I could go, okay, I can directly add the article information to the prompt and I can use it. If the amount of data which is available in the article is quite large, thereby I cannot use it as a prompt and it is not recommended to go with the RAG. I should go for the fine tuning. Okay. But the amount of content in the article is neither too small nor too long. In such cases, RAG is the suitable alternative. Now I want to build a RAG application. Okay. I want to build a RAG application in order to know more about this article and learn all the subtleties of the text available in the article. Okay. Harness API. Harness API, which is available in the archive. This is the article. This is the article and which is published on 21st May 2026, yesterday, or which is posted here, sorry, which is submitted on the 21st May 2026 and which is available from 21st May 2026. This is the article. I just want to know about this article, and if I start reading about this article, it takes a lot of time for me to understand. Thereby what I want to do is I want to take help of an LLM. Okay, whenever I give the whole content to the LLM, it takes a lot of time, and LLM can generate a long responses, and again it takes a lot of time to understand the responses. Rather than that, I just want to interactively understand this article from the LLM. In order to understand this interactively, I want to build a system, or I want to build a question and answer sort of system. Okay, and in order to build that, first I need to add this content to the RAG or add this content to the LLM through the RAG. In order to do that, first I load the document. To load the document, there are many document loaders available in the LangChain. If you open the LangChain library, LangChain docs, in the LangChain docs, go to the LangChain Python. In the LangChain Python, go to the integrations. In the integrations, all the components required for the RAG are available. The first component required for the RAG is load the data. Okay, maybe your data is available in different format. Maybe it's from a text format, or a PDF format, or a MS Word format, or a CSV format, or a .html format, or your data is available in any of these formats. Now, from these formats, if you want to load the data, okay, you can use these document loaders. A lot of document loaders are available in the LangChain, which will help to load data from any format document. Okay, once you load this data, the next step after doing this is, as we discussed, chunk the data. Divide the data into chunks. Okay, in order to perform this, we can go with the text splitters. Once you chunk the data, you need to convert this data into the embedding models. There are embedding models available. You can convert this data into the embeddings. Okay, once you convert this into the embedding models, okay, you need to store these embeddings at some place. In order to store the embeddings, many vector stores are available. Okay, once these embeddings are available, then compare your query with the embeddings available in the vector store and retrieve the top 5 or retrieve the top chunks. This can be done with the retriever. And once you are done with the retriever, then give this data into the model. This can be done with the help of chatbots. all the steps of RAG is available in the LangChain integrations. As far as RAG is concerned, there are mainly 3 steps in the RAG, out of which the first one is, I'll write here. Okay. I have shown that in diagrammatically, but I did not write here. There are mainly 3 steps in the RAG application. First one is the indexing. Indexing means load the data. Okay. Your data may be in any format. Convert this data into the LangChain document object. It is called as loading the data. LangChain document object. Load the data. Once after loading the data, next step is split the data with the help of text splitters. Once after splitting the data, already we have seen this process. Once after splitting the data, convert the chunks into the embeddings. Once you convert the data chunks into the embeddings, store this into a vector database. This is the first step, called as indexing. Second step is retrieval. In the retrieval, query is compared with the chunks available in the vector database. And top chunks are retrieved. And added to the prompt. This is the retrieval. And the third one is the retrieved chunks added to the prompt is given as an input and generate the output. These are the 3 stages in any RAG application. And we have seen the 3 stages through this article. Here. Where is that article? Yes. This is the article. We have seen the 3 stages. What is the first one? Indexing. Data, clean, load the data, clean the data, chunk the data, embeddings, and store. Indexing. Now, retrieve. Take the query, convert the query into the vector, and compare this query with the chunks, and get the best top 5 chunks. Retrieval. And add these top chunks to the prompt and give this prompt to the LLM, generate the answer. This is the generation. These are the 3 steps in any RAG application: indexing, retrieval, and generation. Now we are doing our indexing operation. As a part of indexing operation, first I have loaded the data. To load the data, I have used this web-based document loader, and I have given the HTML format of the Harness API research article. And with the help of this web-based loader, the article is loaded. Or what is meant by loading? Converting any format of document into the LangChain document object. Now see this document. This is the LangChain document object. I have converted the HTML format of the document to the LangChain document object. This is called as data loading. My data is loaded. Once the data is loaded, next step is the splitting the document. Now, to split the document, I have used this NLTK text splitter. Whenever I use NLTK text splitter, NLTK is a library which deals with the text processing, text processing and text analytics tasks. Okay. Now, with the help of this NLTK, in the NLTK we have a tokenizer named as punctab available. With the help of punctab, I want to split the data into the different chunks. Thereby, I have loaded this NLTK text splitter, and I have divided the data into, and I want to divide every chunk as a 100 tokens. That is 1,000 words. Okay. Now I'm using NLTK text splitter. Thereby, I want to convert this document, the whole document data into chunks. And I want every chunk is of not perfectly 1,000, around 1,000 words. Every chunk is of around 1,000 words. And between every two chunks, have a overlap of 100. That is, for example, my chunk 1 consists of word 1 to word 1,000. My chunk 2 consists of 900 word to the 1900 words. 900 word to the 1900 word. Just a 100 overlap. Chunk 3 consists of 1800 word to the 2800 word. Okay. I have maintained a overlap of 100. A overlap of 100. With this overlap of 100 and with the number of words as 1,000, okay, I have divided my whole document into the chunks. Now, with the help of NLTK text splitter, I have divided my whole document into the chunks, and these are the chunks. This is the first chunk. This is the second chunk. Okay, every chunk is a LangChain document object. Third chunk, fourth chunk. My whole document is divided into around 47 chunks. My whole document is divided into 47 chunks. Okay, I have some queries. Why overlap? Okay, in order to have the continuation in the context, overlap is always recommended. Okay, for the continuation in the context. Okay, fine. Okay, let me please share the device class videos. Okay, they will share. I think they'll share. Even my last workshop videos are available in the Full Stack Experts channel. It is based on the resume analyzer tool using multi agents. In the same way, even they keep these videos available to the public. You can browse, you can watch these videos afterwards. Okay, perfect. Now my data is divided into the 48 chunks. Once it is divided into the 48 chunks, then the next step is converting these chunks into the embeddings. In order to convert chunks into the embeddings, you can either go for the OpenAI embeddings, Gemini embeddings. There are many proprietary models, many proprietary embedding models available. But one problem with this proprietary embedding models is whenever your data size is large, the number of tokens consumed is high. Thereby it incurs good amount of cost, or it can exhaust your free time. Okay, even you can go with the Gemini embeddings. Okay. Import the Google generative AI embeddings. Okay, and this is the name of the Gemini embeddings, Gemini embedding 2 preview. And you can convert the given sentence. Here my sentence is hello world. Given sentence into this is the embedding. This is the Gemini embedding of the sentence hello world. The sentence hello world. Okay. Now if you look at the vector size 3072, that is hello world is converted into hello world is converted into a vector of length 0.5, 0.25, so on and so forth, of length 3072 elements. 3072 elements. This is the word embedding of the, sorry, this is the sentence embedding of the sentence hello world. Sentence embedding of the sentence hello world. Okay. If you want, you can have other sizes too. For example, if you provide output dimensionality is 768, thereby the hello world is now converted into the 768 dimension embeddings. Or if you want, you can go with the 1536 embeddings too. See, these 768 and 1536 are the embeddings of the GPT models. 768 is the embedding dimension of the GPT-2 model. 1536 is the embedding dimension of the GPT-4 and GPT-5 models. Okay. We can either go with the 768 size embedding or 1536 size embedding. It is up to us. But only problem with this is, if you use the proprietary model embeddings, it will consume a lot of tokens. Thereby, maybe your free tier may exhaust. Your free tier may be exhausted. Because of that reason, I'm not using any Gemini embeddings or proprietary model embeddings. I go with this sentence transformer embeddings, or I can say these are the open source embeddings. Open source embeddings. This is the open source embedding model, sentence transformer. I have imported this sentence transformer. Once I import this sentence transformer, I have given three words. Three sentences. The weather is lovely today. It is so sunny outside. He drove to the stadium. Okay. For these three sentences, these are the embeddings. And the size of the embeddings is around 374. Okay. I have not typed here. I'll run these cells. The size of the embeddings are around 374. Around 374. I'll just type this. Length of embeddings of 0. 7. Okay. The size of the embeddings are 768 sized embeddings. 768 sized embeddings for the sentence transformer. If it is the Gemini, it is 3072 sized embeddings. Okay. And if you want to find the similarity, just provide dot similarity and provide your embeddings. Thereby similarity between first one to first one to second one, first one to third one. A similarity matrix is displayed here. Okay. This is how you can convert your sentences into the embeddings. First sentence, embedding of the sentence, size 768. Second sentence, embedding of the sentence, size 768. Third sentence, embedding of the sentence, size 768. And with the help of a method named as similarity, okay, the similarity between the first sentence with the first sentence, or first sentence embedding with the first sentence embedding, always one. First sentence embedding with the second sentence embedding, first sentence embedding with the third sentence embedding. Second, okay, first with the second with the third. Okay, all the similarities are calculated here. Okay, and whenever I say similarity, by default it's a cosine similarity, unless otherwise mentioned. Unless otherwise specified, other similarities like a Euclidean or Manhattan or something else. Okay, mostly it is a cosine similarity. Okay, now what I will do is I'll convert. Okay, now I want to convert. Okay, I want to convert my. I want to convert the chunks. 47 chunks we have previously. 47 chunks of data we have previously into the embeddings. Okay. In order to convert that to the embeddings, what I have done, I have created a vector store. Mostly people go with the vector databases like ChromaDB or other database like Milvus, VV8. Mostly people go with the vector databases. But if I start using vector databases, I cannot really get into the vectors, and I cannot really see what is happening with the vectors. Because of that reason, I'm using this in-memory vector store. That is, I'm using my local vector store, or I'm using my local variable as a vector store, rather than using any cloud databases like ChromaDB and VV8. Any cloud vector databases. Now I'm using a local vector store. Okay, and in order to use the local vector store, I have imported a function named as in-memory vector store. In-memory vector store, and once I import the function, I have provided the embedding function. What embedding function I want to use? Okay, what embedding function I want to use to convert the sentences into the embeddings. Okay, then whenever I add the sentences to the vector store, directly the sentences are counted into the embeddings. Now, this is the syntax used to add the chunks into the vector store. Vector store dot add the chunks. Thereby, all my 47 chunks are added to the vector store. Okay, because I have provided embedding function here, the every added chunk is converted into the vector. Every added chunk is converted into the vector. If I want to look at the chunks, just provide the IDs assigned to the chunks. For the first chunk, I have given the ID 0, second one ID 1. These are the two chunks. And if you want to look at the embeddings, this is the embedding of the first chunk and embedding of the second chunk. Okay. I have added my vectors into the vector store, and because at the time of instantiating the vector store, I have provided the embedding model. All the chunks are by default converted into the vectors. Okay, once these vectors of chunks are added to the vector store, the next step is finding the similarity. Next step is finding the similarity. To find the similarity, I need to provide my query. What is the query I have? What is the ID of Harness API? I have provided my query. Internally, this query is converted into the sentence transformer embeddings, and this query is compared with all the chunks available in the vector store. And here I have asked for top five similar chunks. Top 5 similar chunks, and these are the top 5 similar chunks. This is the first similar chunk, second one, third one, fourth one, and the fifth one. It retrieves the top 5 similar chunks. This is the first similar chunk. Once it retrieves the top 5 similar chunks, okay, I have combined all the 5 chunks into a context text, and I have added this context text to my prompt. Okay, I think this is not required. Ayyo. Sorry. Edit, undo, delete. I have added my context text to. I have converted all the 5 chunks into a context text, and I have added the context text to the prompt. Context text to the prompt, along with my query. What is Harness API? What is the idea of Harness API is the query, and I have added the context to the query. Once I add context to the query, and I provide this prompt as input to the model, thereby my model, instead of saying it is not this is not in the purview, or this is beyond the cutoff date, it gives the information about the Harness API. And in fact, this information is correct. Okay. This is how you can build a RAG. And these are the steps which are involved in building a RAG model. Steps which are involved in building a RAG model. We'll just revisit the steps. First, we have asked a question to the LLM that explain the idea of Harness API. But LLM is saying that this is a very recent article, or I don't have any information about this Harness API because the cutoff date of LLM is around 2024 or 2025. Thereby, our LLM cannot give the information about this. And then my idea is, if the amount of information is small, I can add it as a context, but it is not very small. If the amount of information is large, I can go for a fine tuning. It is not as large for fine tuning. Then I have started building the RAG application. To build the RAG application, first I have loaded the document. What is meant by loading a document? Just convert any formatted document to the LangChain document object. This is the LangChain document object. Once I have converted this document to the LangChain document object, next step is divide the whole document into the chunks. Okay, with the help of text splitter. With the help of text splitter, I have divided the document into the chunks. Thereby, I got around 47 chunks. And once I get this 47 chunks, I have added this 47 chunks to the vector database to convert these 47 chunks into the word embeddings, into the sentence embeddings. In order to convert this to the sentence embeddings, I may go with the proprietary models, but the number of tokens it consumes becomes quite large. Because of that reason, instead of using Gemini embeddings, I have used the open source sentence transformer embeddings. With this sentence transformer embeddings, all my 47 chunks are converted into the 47 sentence vectors or sentence embeddings. Once these 47 sentence embeddings are created, then are created, those are stored into the vector store or vector database. Okay, I can use the proprietary vector databases or some vector databases like ChromaDB or Quadrant, Milvus, Face, Pinecone. There are many vector databases available. I can go for any one of the vector database. But to know more about what is happening inside the rack, I have used the in-memory vector store, or I have used the memory which is available with this Colab notebook. Thereby, I have stored all my chunks into a variable named as vector store. Now, to visualize these chunks, these are the first two chunks. First chunk with ID 0, second chunk with ID 1. Further, I have converted these chunks into the sentence embeddings. This is the sentence embedding of the vector ID 0 chunk, and next one is the sentence embedding of the ID 1 chunk. Then once all the chunks are converted into the vectors, then I can go for the retrieval. And in the retrieval, first I go with the similarity search, and first I compared my query. What is the query? What is the idea of harness API? This is my query. I have compared this query with all the chunks available in the vector store, and I asked this function to get the top five chunks. Whenever I say top 5 chunks, top 5 similar context chunks. Thereby, it returns the top 5 similar context chunks. Then I have added this top 5 similar context chunks. I have converted the top 5 similar context chunks into a text file, into the text format. Then I have added this text as a context to my prompt here. This is my prompt. I have added this as a context and along with the query. Thereby, my LLM can answer the question, what is the idea of harness API? Okay. This is how you can build a simple RAG model. Okay. Yes. 7 queries. How to add API key into the secrets in Colab notebook. At the end, we'll see that. Why overlap? I have already answered. How is 100 decided for overlap? Okay, this is really a good question. First to try with the 100 overlap and the 1000 words as a chunk size. And once you get all your responses, then evaluate the responses. If your responses are not good, then you can revise these sizes. Okay. For example, your response does not give enough information as which is expected or which is desired. In such cases, try to increase the chunk sizes. Or it is giving over information, try to reduce the chunk sizes. Okay. In absence of overlap, nothing will happen. But it's a good practice of giving the overlap. How to calculate hello world? See, this is a quite philosophical question, and to discuss this, how to convert this hello world into a vector which can really communicate the hello world, it is it is really a 1 week worth discussion again. Okay, and for you, okay, if you want to really understand this, there is an article written by J. Almer, and the name of the article is the illustrated word to vec or illustrated. Okay, I'll just open this article. J. Almer's word to vec. J. Almer's word to vec. Word to vec. The illustrated word to vec. This is the article. Just go through this article, then you will understand this. Okay, how a sentence is converted into the vector. You can understand this well. Okay, this is a very good article to understand this. Okay, then next question. What is the final output being extracted directly the paper? It's in fact generic. It is not directly copied from the paper. It is generic in fact. The answer is really generic. You just read the answer. I have shared the notebook to you. Just look at the abstract of the paper and read the answer once. Thereby you can understand the answer is quite generic. It is not directly copied from the paper. Please put the reference of videos in group, sir. Okay. I will do it. I'll do that. With this can query any type of yes, any type of research paper. Just what you need to do is go to the archive. Go to the archive. Okay, in the archive, you will find, for example, this is the Harness API paper. Click on the HTML experimental, copy the link, copy the link, copy the link, go to the notebook, go to the notebook. In the document loader, in the document loader, I have given the link here. Go to this link and paste here and run the remaining cells. Run the remaining cells. Thereby, at the end, I have asked some question here. Go to the generation. In the generation, I have asked a question here. What is the idea of Harness API? Here you can post, you can ask your question and it will generate the response. Okay, you can do this with any research paper and any article of your choice. Without using all of, how is the authenticity of the extracted output verified? In fact, see, there is no mathematical proof that there is no clear, there are no hard and fast rules that overlap is mandatory. Okay, just if you want, you can add the overlap and see, adding overlap is a best practice. It is not mandatory. There is no mathematical proof. Okay, what I recommend is adding some overlap. Add some overlap. Okay, if you found that overlap is really doing adding some repetitions in the data, doing something else in the data, thereby you can get rid of it. But the best practice is add some overlap. If the answer is generic, okay. Sorry, Mike. Okay, I think I don't understand what do you mean by generic? Okay, what I understood from your previous question is this answer directly copied from the research article, or it is understood and generated by the model? My response is it is understood and generated by the model is my response. Okay, I think I did not understand what exactly is this generic means. Okay, could you please elaborate what is this generic? Thereby I can address this question again. See, for creating greeting cards and invitations, no need of building an application using LangChain. Just provide the you just provide your open Nano Banana and type your prompt. Thereby it will create very good images. Not just open banana, there are many other. Can RAG be used for work on literature review of papers? I'm not pretty sure what type of or what methodology you are following in the literature review. But if you want to really search for an articles, not just RAG, this agentic AI application, this generative AI applications are quite useful. Okay, in the next example, I'll show you. Now I have given directly the Harness API article to the Harness API article to the LLM. In the next example, what I'll do is I'll give a problem and I ask LLM to search for a research article which solves this problem. A research article which solves this problem by giving a tool, a web search tool. Okay, I'll show you that. By general answer, it is no. It is not the general answer. It is the answer. It is the correct answer or very fair answer with respect to the general article we have provided as a content. Okay, now This is about the building a simple RAG application. Once you understand this idea of RAG and once you understand the flow what I have given here. See, even with very small piece of code, I can implement this RAG. But intentionally, I have given the whole. I have written the whole code to make you understand every step in the RAG. Once you understand this RAG, it will be quite. Then this will be very helpful to understand the further different types of the RAGs, different types of RAGs. Okay, now. Now we'll go to the next step. Is it? Now, what is this agent? Agent is a autonomous NOMOUS. Okay. An autonomous agent, an autonomous entity or element in a workflow. In a workflow, whenever I say autonomous, it can make decisions. It can make decisions. Okay, and the main idea of the agent lies in the main idea of the agent lies in the tools, or people call it as a tool calling. People call it as a tool calling. That is, whenever you add, or we cannot say add, whenever you bind LLM with some tools. Whenever I say tools, it might be a search API, it might be a search API, or it might be an API which can perform, or an API which can extract, okay, rather than writing extract and all, a dictionary API. A search API, okay, so on and so forth. These are called as tools. Whenever you add some tools to an, or we cannot call it as yet, whenever you bind some tools to an LLM, okay, then LLM can make the decision autonomously about which tool is suitable for the customer query. Which tool is suitable for the customer query. Okay. This type of autonomous decisions are made by the agents. Okay. Whenever you add any tool to the, whenever you bind any tool to the LLM, then LLM will make a decision regarding which tool. For example, if you add 10 tools to an LLM, then based on the user query, which tool is really suitable to answer the user query, and which set of tools are really suitable to answer the user query, and in which order these tools are employed to answer the user query, in which order the tools are employed to answer the user query, Okay, all these decisions are made autonomously. First one is which tool is suitable for the customer query, or which set of tools, not just a single tool sometimes, which set of tools are suitable to answer the customer query, or in which order the tools are employed. In which order the tools are employed in order to answer the user query. If these decisions are made by the LLM in a workflow, then in an element of a workflow, then that element is an agent. If you build a workflow with these agents, those are called, if you build a workflow with agents, those workflows are called as agentic workflows or agentic AI. Agentic workflows are agentic AI. Okay. This is what exactly the agent is. An agent is capable to take the decision autonomously with, okay, whenever you bind a tool, whenever you bind a single tool or a set of tools to the agent, sorry, to the LLM, then if that LLM is able to decide which tool is suitable to respond to the user query, or if that agent is able to decide, sorry, not agent, if that LLM is able to decide what set of tools are really required to answer the user query, and if that LLM is able to decide in which order the tools are employed to generate or give response to the user query, okay, this behavior is called as agentic behavior. And if you build elements with agentic behavior, okay, in a workflow, those workflows are called as agentic workflows or agentic AI. Okay, this is what exactly the agent is. Other than attendance link, if any queries, I'll answer. Okay. See, no need of having another session. Just go to the Full Stack Experts website. In the Full Stack Experts website, Full Stack Experts YouTube channel. In the Full Stack Experts YouTube channel, you will find a 3-day workshop for building a resume analyzer tool. That is enough to understand the same this agentic AI, or that is enough to understand how to build an agentic workflow. Okay. Now I'll show you. What is this agentic behavior. Agentic behavior. In fact, this agentic behavior is best explained with the help of something called as React loop. As we have discussed, this React loop mainly consists of, in the React, re means reasoning, act means acting. Reasoning plus acting along with the observing. This loop is called as React loop, and all the agents behave in the same way. This is called as React loop, or this communicates the agentic behavior. Now we look at what is this React loop. Yes, React prompting. In fact, rather than React prompting, it's a React loop. Okay, React loop, it mainly interacts between two things. One is the acting, another is the reasoning. Reason and act according to it. Reason and act according to it. This is called as React loop. And these are the three main steps in the React loop. One is the reasoning, second one is the acting, third one is the observing. Okay, what is this reasoning? Based on the user query, okay, just reason the user query. Based on the user query, agent thinks the problem through step by step, and search for a tool. Once it search for a tool, then it executes the tool and get the response. Once the response is observed, based on the observations, again agent reasons. And based on the reasoning, it runs the tool. And after running the tool, it observes the output. And after observing the output, again, it compares this output with the user query, and again reasoning, acting, observing. This loop repeats till the response of the response of the agent, a response given by this agent is is a good response or is a suitable response for the query. Okay, until LLM generates the suitable response, this loop repeats. Okay, reasoning, acting, and observing. Reasoning, acting, and observing. This is a loop which performs. Okay, this is a loop which performs based on the user query, and till LLM generates the best response to the user query, this loop will repeat. Okay, I'll show you an example how this loop will repeat. I'll show you an example. Yes, agent. In order to run these agents, first I have started with a Grok API. I have installed LangChain. In the LangChain, we have many tools available. If you go to the LangChain integrations, there are many tools available. Yes, this is the LangChain integrations. Just look at this. Not here. Just look at this tools and toolkits. There are a lot of tools available. There are many such tools available, out of which one such tool which is available for free and without any registering and all, we can use one such tool named as the DuckDuckGo search. DDGS, DuckDuckGo search, and it is quite popular. DuckDuckGo search. We can use that search tool, and you can add the search tool to the agents. I frequently go with the DuckDuckGo search, even though there are many searches available. For all these searches, you need to register or you need to take the subscription. Instead, I always go with the DuckDuckGo search. Not just DuckDuckGo search, there are a lot of tools available. You just scroll this page. These are the different tools available to perform some tasks, and this task will be managed by the LLMs in the agentic manner. Okay, I have imported a tool named as DuckDuckGo search, and I want to know who won the yesterday's IPL match between the Gujarat Titans and CSK. Okay, I want to know the result of this match. If I ask the same question to the LLM will answer that I don't have enough. I don't have. This is the future. I don't have information about the 2026 IPL match between the Gujarat Titans and the Chennai Super Kings. Thereby, what I can do is I can go with the DuckDuckGo search. And I can get the answer for this query. Who won the IPL match between Gujarat Titans and Chennai Super Kings? Thereby, it has given the answer. Gujarat Titans won the match. Okay. Whenever I have such tools available, rather than calling these tools independently, I can add these tools in my workflows. And these tools, no need to manage these tools, monitor these tools manually. Our LLM will monitor this tool with the help of React loop or with the help of reasoning, acting, and observing. In order to carry out this reasoning, acting, and observing, we have one syntax available in the LangChain called as create agent. With the help of create agent, it is possible to create an agentic behavior workflow. Create an agentic behavior or create an agentic workflow. Now, but these agentic workflows need some tools. In order to have a tool, I am using this DuckDuckGo search. I have imported the DuckDuckGo search, and I have converted this DuckDuckGo search into a tool by adding a tool decorator. Thereby, this DuckDuckGo search is eligible to become a tool for the LangChain agentic workflows. And this is the syntax used to create an agent, and the syntax is create agent. And the model I am using, or LLM I am using, is the Grok LLM. And the tool I want to add here is the web search tool. And I have added a web search tool. This is my agent. Now this agent, whenever user asks a query, this agent go on interacting with the tool in the form of a loop. Reasoning, acting, and observation. Reasoning, acting, and observation. This loop stops only when the response given by the tool is suitable for the user query or is answers the user query. Until this point, this tool runs. The same is communicated with this arrow marks. I have created a simple agent and I have added a search tool to this. Here the tool is the search tool. Then I have asked the question, who won the IPL match between Gujarat Titans and the Chennai Super Kings? Thereby, a continuous because this question is not directly answered by the LLM. This question is not directly answered by the LLM. LLM start interacting with the tool and follow the React loop. Through this React loop, LLM will with multiple interactions with the tool. LLM gets the response, and you can see this. First, as a human message, I have asked a question: who won the IPL match between the Gujarat Titans and Chennai Super Kings? Then, because LLM cannot answer this, AI message is the LLM. LLM cannot answer this. LLM assign this question to the tool. Then, LLM continuously interact with the tool and it interacts with the tool till LLM gets an answer that Gujarat Titans own the IPL. Till LLM gets an answer that Gujarat Titans won the IPL match between Chennai Super Kings and the Gujarat Titans. Until that point, LLM go on interacting with the tool, and this interaction by following the React is called as uh, React loop or agentic behavior. And in order to make you in order to communicate you, this is not just for the toy examples, even for your day-to-day examples or even for our day-to-day tasks, we can use this React. We can use this React loop in the form of a create agent by the LangChain. Now I have asked a question to the now I have asked a question to this agent, and the question is: find a research article or technical paper which can address the following problem. The developers register for both the HTTP and the MCP protocol. It becomes duplicated. In order to do that, I just want a solution. I have just asked a question in that way. Thereby, and for that I have added this web search as a tool. Thereby, my LLM go on interacting with the LLM. This is the question I have. My LLM go on interacting with the tool for multiple times here because the question is complex. Thereby, LLM go on interacting with the tool, and at the end, my tool answers the query as very recently a research publication. A research article is available, and in that research article, this problem is solved, and the name of the research article is the Harness API here. Very recently, research article is published. The name of the research article is the Harness API. This Harness API, this article solved the problem. Okay, it is not just limited to the toy problems like who won the yesterday's match. Even you can use this for getting just knowing getting some articles or to search internet thoroughly. Okay, this is about how to employ agent for our day-to-day tasks, and this is all about the agentic behavior I want to explain, and the RAG application. Okay, and this is whole about the today's session. And today I want to communicate one more thing. Maybe in the next 24, 25, and 26. Okay, I just show the. I think already you got the mails regarding that. Regarding that, what is this? A placement drive, which is uh, conducting by by Inomatics Research Lab at Bangalore and the Pune. Where are these images? Okay, I cannot search those here. Minimize, and even I have the flyers available. Where are the dots? Where are these? Okay, here. Okay, just I want to communicate this. Okay, a placement drive is organizing by the Inomatics Bangalore and the Inomatics Pune branches with the Infosys. Please encourage your students to attend these drives and make this successful. This is one thing I want to communicate to you. This is one thing I want to communicate to you. One at the Pune and another at the Bangalore Infosys. Just communicate this to the students. And as far as certificate is concerned, by Wednesday evening, you will get your certificates through your mail through the mails. Okay, by Wednesday evening, you will get your certificates. And this is the today's attendance link. Scan this attendance link and fill the today's attendance. Okay, if you have any queries, I'll answer your queries. Along with that, I am posting this attendance link here. Okay, and I'm pinning this attendance link. Inomatics Bangalore and Pune is conducting the Infosys drive at our premises. Just encourage your students to attend this drive and get placed. Okay. In the meantime, I'll go through this chat box and try to address the queries if any posted. Okay, this drive is organizing at our premises, Inomatics Bangalore and Inomatics Pune premises. Okay, thank you. Kindly share the attendance. Okay, by mistake, repeatedly are posting the same WhatsApp group link. In fact, we are not from Inomatics side, we are not posting any WhatsApp group, and I don't recommend joining these WhatsApp groups. This is not for our from our side. Okay, already I have shared the attendance. Please fill the attendance, and if you have any queries, you may ask your queries through the chat box. I'll answer. And uh, already you got you got mails, or you may get mails regarding this placement drive organized by the Bangalore and the Pune Inomatics at the Inomatics premises by the Infosys. Encourage your students to attend. And by Wednesday evening, you'll get your certificates of this FDP program. And very soon, I think these videos will be available to you through the Full Stack Experts YouTube channel. Okay, I cannot share this to the Google Drive, even though because it is available in the YouTube and these are recorded in the YouTube. Soon our team will share this through the to you through the YouTube channel Full Stack Experts Academy. Okay, thank you. Already I have shared this notebook link. I think I have shared the notebook link multiple times from the day one and from the day one onwards, and I have been using the same notes or same collab notebook from day one to till the last day. Okay, I have a doubt. LLM can decide which tool is suitable for the query. Then only reasoning, acting, and observing, and until stop. Is it correct? Okay, here it's a good question. Uh, whenever user asks a query, okay, LLM look at the first LLM try to understand LLM understands the query, thereby LLM will decide which tool is suitable for answering the query or which set of tools are suitable for answering the query, and in which order these tools are employed to answer the query. This can be autonomously decided by the LLM, provided your LLM supports the reasoning task. Provided in your tool definition, you must provide a document string and mention the what is the functionality of a tool. Okay, these are the two things you need to remember. First thing is your large language model have the reasoning capabilities, and almost all the recent large language model have the reasoning capabilities. Don't bother about it. And the second thing is, whenever you're writing tool definition, I have shown you at the rate of tool. Whenever you are writing tool definition, you must provide a doc string which communicates what functionality that tool is offering. Thereby, thereby LLM can make this decision autonomously. Yes, Pune and Bangalore and Infosys Drive. I think maybe you will get mails regarding this. Okay, you'll get mails. You'll get mails. Hmm. Okay, this is really again really a good question. How can a person from non-programming background can create an agent? Okay, for you, there are few tools available which do not require any programming. Out of which one tool is the proprietary tool or paid tool that is called as N8N. It is a paid tool, and very similar to that N8N paid tool, you have one more tool named as LangFuse. So not LangFuse, LangFlow. Okay. Uh, I'll write those tool names. Okay, a paid tool, it is N8N, and an open source tool is available, and a open source tool is also available. And a open source tool is also available. It is Langflow, and in future you'll get many number of such tools. In future you'll get many number of such tools. This is just starting as far as I'm my thinking is concerned or my knowledge is concerned. Okay. Use any of these tools for your for building the agentic workflows. The placement drive is for the 2023, 24, and 25. Okay. Can you provide a roadmap for AML architect? In fact, it is really a very hard job outside AML architect, and still people are struggling to find out how to design these AML applications. Okay, but very recently people are coming up with some architectural some architectural information or some architecture articles. Okay, and you cannot find this information through any books and all. You need to look at the articles in the internet. There are few people who started writing how to design these AML workflows, and there is There are few books too. I think one book you may aware of and it is very popular. It is AI Engineering by Chip Huyen. This is one book. Along with that, there is one more book named as LLM Engineering by Paul Lichtenstein. I have shown you one article today for this RAG architecture, for the RAG diagram. It is written by a person named as Paul Lichtenstein. He has written a book named as LLM Engineering. This is really a good resource to know about the all the aspects related to the LLMs. Okay, and very soon you will find good articles and good books pertaining to the AML architect. It is still a hard role, and still people are figuring out very good ways of doing it. Okay, and I'm not much aware of very good articles pertaining to the AML architect, and all the information is in the bits and pieces. Yes, in order to communicate to you, there is one tool available, and that tool can help you, and that tool can answer your queries. I'm showing this web search tool. If any tool which can answer or which can do a particular task, you can add that tool to the LLM. You can add that tool to the agentic workflow or LLM. Thereby, you can make your LLM interact with the tools. What I want to communicate is, if you have any tool which has some capability or which performs some task, you can add the tool to the LLM and make your LLM interact with the tool and create an agentic behavior or create an agentic workflow. This is what I want to communicate. Okay. See, since day one, I have been sharing this collab link. The same collab link I'm using for all the 5 days. Okay. If it is not updated, just reload the collab link, open the collab link and reload the file. Thereby, you will get the updated code. Yes, yes, we always conduct this type of sessions to the students also. Even for the students, we conduct this type of sessions. Very recent, I think around not 1 month back or around 1 month back, I have delivered one session to build the resume analyzer tool for all the students. For all the college students of colleges who are having MOE with us. Okay, and even that videos are available in this Full Stack Experts Academy YouTube channel. Okay. In fact, ChatGPT and Claude. In fact, ChatGPT and Claude are the applications. You cannot use these applications to build the agents. You need an LLM to build the agents, because LLM can interact with the tool and set an agentic behavior. You cannot use these applications to build the agents. And for the applications, in order to have this type of in order to have things to be done automatically or things to be done by default, by adding a small piece of code, some agentic skills are available. PDF of the notes you have written. I'll try to share. I'll try to share my annotation notes. It's a 5-day notes. I need to first convert into 5 PDFs and I need to merge this. Okay, I'll do that. Okay, what I'll do is keep my collab notebook with you. I'll update this 5 days notes into my collab, and I'll share that link into the Google Drive, and I'll share that link through the collab. Okay, at the starting of the collab, I'll add the Google Drive link. That link will give you the access to my 5 days annotation notes. Okay, I'll share this information through the collab. Just keep this collab link with you. Okay, I'll again post the collab link once. Keep this collab link with you. Okay, right after the first cell here, at the first cell, I create a cell, and I'll provide you a link here. Just browse this link. Maybe By the end of tomorrow, I'll do that. Today I cannot. By the end of tomorrow, I can do that. Okay, some platforms and resources to learn all these things. All they have shown you one thing called as decoding AI. Okay, in the decoding AI, you find some articles, and these articles are quite suitable or quite helpful to build the agents and this RAG. Okay, those are really good articles written by the Paul Legistin and the team of and his team. Just go through go through those articles. Those articles will be helpful. This is one thing. And the another thing is to learn this LLMs. um, to learn this LLMs, another thing is just to go through the Chipyun's books. Those books are quite good to understand these LLMs, and go through, and because you are in the academia, rather than going through the articles, it would be quite good if you go through the Stanford online lectures. There are very good Stanford online lectures, very high quality Stanford online lectures available. Just go through that. I think you can understand. You people have good understanding on the math and about the good understanding on mathematical topics. Thereby you can learn these things very well. Okay, very recently Stanford Online has delivered or has shared their lecture videos on transformers and the large language models. You can go through it once. That will help you. What future improvements do you expect in LLMs? Uh, what future improvements means, that we cannot predict. In fact, every day or every month we are getting some surprises in the AI area. Okay, thank you very much. Okay, okay. Okay, please contact. Yes, we are conducting this type of workshops even for students too. Okay, you just contact with your coordinator. Coordinator will communicate to you. We are conducting the same to the students. Okay, you will get entire recording through the Full Stack Experts Academy channel. Okay, soon. Not by Saturday, next week Wednesday evening. By next week Wednesday evening or by next week Thursday, you will receive your certificates. Okay, if you are very interested for MOU, just contact this program coordinator. Okay, the contact the person who sends you the mails, and the person who communicated this information to you. He'll be doing all this. Okay. Okay, today's attendance link. I'm sorry. Yes. Just scan this and you'll get the today's attendance. Okay, if you want to have an MOU with Inomatics, our coordinator, just contact our coordinator. Otherwise, I'll just go through the. I ask him to go through this chat and contact you. I am not pretty sure about this. So the second one, how can we connect with you and reach out to you? Okay. If you want to reach out to me, just contact the coordinator who conducted this workshop. A problem in internet. Again, I'm repeating, we are conducting these type of sessions for all the students, or all the college students who are having MOU with us. Okay, this is fine. Attendance link. Is drive online or offline? It seems it is offline. Thank you. Arrange FDP only an agentic case sometime. Maybe in near future it is not possible. If you just contact, just be in touch with the pneumatics coordinators or pneumatics. What is this? Communications. Thereby you'll come to know about. Thereby you will soon you will get one invite for that too. Can save only collab copy. This will not get updates with the slides. See, just uh, keep this collab link with you. Keep this collab link with you. Just save it somewhere and maybe open this collab link maybe on the Saturday evening or Sunday morning. By that time, I'll add one cell at the starting of the collab and I provide this link. I provide the link of a Google Drive link for this 5-day annotation notebooks. Okay, have compiled the 5-day annotation notebooks into a single PDF and I'll provide a link. Okay, if it is required, it would be helpful to you if you want to really go through it. Okay. Perfect. Perfect. Okay. Thank you. Thanks for your patient listening for the past 5 days. Hope you uh, hope you enjoyed and hope you learned something from this workshop. Thank you all.